Imagine an energy source that is practically limitless, has no fuel cost, and has no carbon dioxide emissions. What if I told you that we already have it? It's called the sun. No discussion on sustainable energy is complete without solar energy. And while there are an ever-growing range of solar technologies and applications, let's first get an understanding of the basics. We all know where it comes from, but what is it? And how much of it does the Earth receive? Once we know that, then let's look at the main methods of harnessing this incredible energy resource. Solar energy comes in the form of electromagnetic radiation, which is basically waves of heat and light radiating from the sun. This diagram shows what the Earth's spectrum of incoming solar radiation looks like from an energy perspective. On the y-axis is the spectral irradiance. In other words, how much energy per square meter. And on the x-axis is the wavelength of the incoming radiation. The wavelengths are broken down into three common categories. On the left, you can see UV or ultraviolet, which are the shortest wavelengths. Next are the visible wavelengths, which is the light that we actually see. Then, on the right, are the infrared wavelengths, which are the longest. In yellow, we can see the incoming solar radiation that reaches the top of the atmosphere. In red is the radiation that reaches the Earth's surface at sea level. Different compounds in the Earth's atmosphere, like water, actually block or reflect some of the incoming solar radiation. This is indicated by the missing sections in the red area. Now, how much do we receive? If we take all of the solar radiation that hits the surface of the Earth across a year, including the time that the sun's not shining on it, we can calculate that every square meter on the Earth's surface receives about 140 watts of direct sunlight on average. Of course, this number varies depending on the distance from the equator and the typical cloud cover and other atmospheric conditions. To put that into perspective, each square meter of the Earth's surface receives, on average, enough power annually to run your average ceiling fan, while 2 square meters might receive enough to run a plasma TV, and 3 square meters might run a small washing machine. Now, have a quick look and see how many square meters of empty space are all around you. The potential is amazing. So, we know that we receive an enormous amount of solar energy every day. But how can we harness it? Well, there are several ways. Passive use, active use, photovoltaics, and concentrated solar thermal. The passive methods have been used for thousands of years and require minimal technology. The best application of passive use can be seen in building infrastructure with simple design techniques that maximize the impact of the sun. These include building orientation, natural light and heat collection, and thermal differences used to encourage ventilation. Active solar heating uses the sun combined with some moving parts, like a water pump. The most common examples of these are solar hot water systems for households and swimming pools, and basic solar cook stoves. Perhaps the most recognizable method, at least in recent times, is photovoltaics, or solar PV. Typically, we see panels of solar PV cells using the photovoltaic effect to convert sunlight into electrical current. Solar PV is applied on rooftops, in utility-scale solar fields, and even on spacecraft. The third is a less common but no less powerful method in which the solar radiation from the sun is concentrated using mirrors or reflective surfaces to heat a thermal fluid, which is then used to run a steam power cycle to generate electricity. This is known as concentrated solar thermal. The Earth is constantly receiving solar energy from the sun, and we have been using this energy for many years in many different ways. But more recently, we have been realizing the potential to convert this energy into electricity or usable forms of high-grade heat. Solar energy has no fuel cost, very low to no carbon dioxide emissions, and nearly limitless potential. The technology has been developed for us to harness this amazing resource, so what are we waiting for?